So graphing, number 43, growth or decay. Remember, we look at the base. If the base is less than 1, it is decay. If the base is greater than 1, even a fraction greater than 1, it is growth. So, on this first one, as we've been doing, use your calculator and type in for y equals, figure out whatever's in there, and put this in. Negative. I just put 0.5. You can put 1 divided by 2 in, that's fine. But if you use the fraction function in the calculator and actually make a real fraction 1 over 2, you will get fraction answers in your table. So if you want decimal answers, it's up to you. So negative 0.5, 1/2, to the x plus 3, meaning we're going to be moving it to the left. Remember to come down and then put plus 6, which means it's going to be going up. Okay. Now we hit graph. It's flipped upside down because even though we were thinking decay going the other direction, it is flipped upside down because of that negative. We can go to the table and look for points. Okay, and you can put any of these down right here. So -7, -10, -6, -2, and so forth. -5, +2, that's a 5, sorry. -4, +4, -3, +5, and then we start getting into decimals. -2, 5.5, and as we get closer to 0, we get 5.9. So remember, I like to put my asymptote in first. This is my asymptote on an exponential at x equals 6. Sorry, y equals 6. I just made that mistake I tell you not to do. Y equals 6, right there. Okay? I put that in first. Now I start putting my points on here. So -7, -10, -6, -2, -5, +2, -4, +4, -3, +5, and then we're going to start writing out this line right here. Wow, that got weird. Pick up my knuckle. Sorry about that. Write this out as close as possible. There you go. Now, big problem here is people with the A. That's what gives most people the trouble. Remember, A is not 1/2. That's our base. Our A here is -1. We don't see the 1, but we could write it in there. H is going to be -3. Remember, if you have to, set that x plus 3 equal to 0 to remember. And then K is 6. So what are my transformations from the original? The K is going to move it up 6. The H is going to move it left 3. And the -1 is going to flip it. The domain, it's going left forever and right forever. The range, how low does it go? Down towards -infinity, up to, and not including 6. We use parentheses there. The y-intercept we got from the table is 0, 5.9. That's why it was important to put that one on the table. And the asymptote, as I sort of said wrong before, is y equals 6, not x equals, because it's a horizontal asymptote. Okay, on to the next one. You're going to enter it the same way. 3 caret x minus 2 minus 5. I'm not going to spend time putting that in there. You know what it looks like. You know how to do it. When I do that, I'm going to get numbers like, well, 5 is going to be off the table at 22. But 4, -4. 3, -2. Sorry, that 3 is horrible. 2, -4. 1, -4.7. 0, important, negative 4.9, and negative 1 and negative 4.96. If you don't fill out every one of those in the table, it's fine. As long as you get the idea. Now, where is my asymptote? At negative 5. So I'm going to put that right there. Draw that in first. 5 is off the chart, way up here somewhere. 4 is down here at negative 4. You can see, though, how fast it drops. You know, right here at 5, all the way like that. I mean, it's dropping fast. 3, negative 2. Oh, I missed that. Put something in wrong. That's supposed to be 4 positive 4, my mistake. I did not see my negative. But it's still dropping pretty fast. So 5, 22 way up here. 4, 4 is right there. 3, negative 2 is right here. 2, negative 4. And then it's going to kind of bottom out. So, like so. Okay. So, on to analyzing the graph. A. Look very carefully on this at this one. There is no number outside my 3. There's nothing right here. Okay? That does not mean that A is 0, which has been a very common mistake. A is 1. Okay? 1 doesn't change anything, so A is 1. H, we said the x minus 2 equal to 0 and get positive 2. And K was negative 5. So what's happening? The K moves it down 5, and the H moves it right 2. Domain is the same as on number 1. It's going left forever and right forever. Remember, domain is our x values. Range is our y values. The range, how low does it go? Negative 5. How high does it go? Infinity. Now, a lot of people are still putting infinity negative 5 for this. That's wrong, technically. Okay? Because we always go how low to how high. If you think about a number line, negative is on the left, positive is on the right. Keep it that way. The y-intercept is that k at y. Sorry, my bad. I'm getting ahead of myself with the asymptote. The intercept was off the table at 0, negative 4.9. And then the asymptote is y equals our k, which is negative 5. All right. Notice on this one, there's not 2 tables, so you don't have to put the table for the parent function. But if you want to enter it in your calculator, you can. Okay, that's up to you. So remember, for a log, we're going to hit the math key, go up a few to A, log base. We're going to put the 3 in there, go into the parentheses and put in x minus 3, come outside the parentheses and put my plus 1. Now remember, on this one, h is my asymptote this time for logs. Okay? So when I hit graph, you get a general idea what it looks like. Now remember, that it cannot do the pixels as it approaches that asymptote at 3. It just stops. But it's still there. So let's go to our table and look at what we got. Bunch of errors. Well, I got to adjust that. Okay? So that's going to be errors as I go that way. So I need to go up. Nope, went the wrong way. Sorry, not thinking. Words messing with me. Okay, so there we go. So I'm going to put points like so I'm going to put points like 4, 1, 6, 2. And then you're off the chart. So like 10, 2.7, 2.8. Otherwise, a lot of fractions. So 10 is almost at 3. That's horrible. 4, 1. 6, 2. Okay. And where's my asymptote? It's at 3, right here. X equals 3. So that gives you an idea what's going to happen here. It's going to go like this. And then just ride straight on down that line. So you actually don't need a lot of points there. Now, what's my A? Well, remember, there's nothing in front, so it's just 1. My h, set this equal to 0 and get positive 3. And my k is positive 1. Now what's that going to do? The negative 3 is going to move it right 3. Because normally, think about it, if it was a regular log, x would be 0. It's moved over to the right 3 that asymptote has. And it's going to move up 1. Now my domain, remember, now we're switching. It doesn't go left forever because it cannot pass 3. So my domain only goes, that's horrible, my domain only goes to 3. How far right? Infinity. Now my range is forever now because it's going down and up forever. My x-intercept, well, where is that? There's the problem. We can't see it. It's not on the table. So we need to do, remember, second trace. Okay? Second trace. We go to 0, hit number 2. Now, right now x is at 0. We need to get out close to 3. So I need to go right. See how it's going? 1, here's 2, then you get close to 3. Now there's the little marker. Now remember, for left bound, I need to be below the line. So I'm going to hit my left key. Notice how it kind of disappeared? I want to make sure it's below the line. So I do that and hit enter. Now right bound is going to be above it. So I'm going to go right a few times, hit enter twice, and there is my intercept at 3.3 repeating, also known as 3 1/3, 0. And the asymptote, remember, now is going to be x equals 3. Moving on. Last one. Okay, so on this one, we're going to enter in, same way we did before, log 2 x plus 2 minus 5 in our calculator. Don't need to do that for you. You've seen how to do it. So when I put that in, I'm going to go to my table. I'm going to get points like -1, -5. 0, -4. 1, 3.4. 2, sorry, it's -3.4. 2, -3. 6, -2. And off the chart at 14, -1. Okay, so -1, -5, down here. 0, -4, right there. 1, a little bit off, almost 3.5. That's 3. Something like that. 2, -3. 6, -2. And out here at 14, -1 somewhere. Now, where is my asymptote? It's going to be at -2, right here. So I throw that in there real quick. And then, I just put my graph going this way, and once I get close to that energy field, I just write it out. Now, I don't know what my x-intercept is. I'm going to have to go on my calculator, so I guess I will show that now, and find it. So A on this one again is 1. H is -2 and K is at -5. What's happening? Well, it's going left 2. It's going down 5. Domain, how far left does it come? -2 to positive infinity. Left -2, right forever. Range, forever going down and forever going up. My x-intercept, well, let's find that real quick. So I come into y equals, clear it out. And I'm going to put math, log base, 2, go into the parentheses, x plus 2, outside the parentheses, -5. I'm going to hit graph. Now obviously, since it's at 14, -1, it's going to go past 14. So I go to my table, and I just keep pushing down on this. If this will work for me, there we go, until I hit 0. See how it's getting, -1/2? Getting close. There it is, 30, 0. Sometimes you just have to ride out the table and find it. And my asymptote, as I said before, was x equals -2. Okay? That's it. Now the next few problems, the word problems, are going to be different numbers, but they will match up. Okay, number 58. $2,000 deposited, 6 years. Here's my principal, here's my time. My interest rate, remember, Beyonce, to the left, 0.051 as a decimal. It's compounded semi-annually. That means we're talking about an n of 2. So let's just use our formula. A equals $2,000 times 1 plus 0.051 divided by n, which is 2, to the n, 2 times how many years? 6. We calculate that out, we get an amount of $27,05.57, rounded. Okay, 59. $3,000, 9 years, 4.9%, 0.049. Monthly n is 12. So we have future value is equal to 3,000 times 1 plus 0.049 divided by n, which is 12, raised to the n times t, 12 times 9, and we get a future amount of $46.58.60. Number 16. So for part A, find the value 8 years, 5,000, 8 years, 3.2%, 0.032. Compounded continuously. So that's our new formula. Remember, that's the A equals P e to the RT. So that's 5,000 e 0.032 times 8, which gives us $6,458.76. Part B, how long will it take to reach 10,000? Now remember, you can do this in the calculator. You can enter y equals 5,000 e 0.0328 times 8 and scroll down until you see 10,000 and then estimate, round. You know, say about this year, this many years, or between here and here. If you do it on here, we're going to write 10,000, because that's our goal, equals 5,000 e 0.032 per time. And now we do the same thing we've been doing. Our first step, get e by itself. Divide by 5,000. That gives me 2 equals e to the 0.032 t. What do I do now? ln both sides, log both sides. That makes 1. So now I have ln of 2 equals 0.032 times t. And then I just divide both sides by 0.032. And we get t of about 21.7 years. If you use the calculator, you'll have to say between 21 and 22 years. Or you can probably tell from the numbers that's going to be close to 22 years. Like I said, either way you want to do it. 61. They give us a formula right here. So all we're doing is plugging in 3,000 n equals 3,000 times 2 to the 5. And when we do that, we get 96,000 bacteria. Don't forget to put in words when it's a word problem. The dollar sign is okay for money, but when you have a word problem, use words. How long will it take to be 12,000? Same procedure. Once again, you could enter this formula right here into the calculator and just search for 12,000, or you can do gold 12,000 equals 3,000 2 to the t divide by 3,000. Okay, that will give us 4 equals 2 to the t. And this one, you don't have to worry about logging because it's just 2 to what power it gives you 4.
x equals, or t equals 2. So 2 hours. 62. The projected worth in billions of dollars of a large company is modeled by this equation. Now, this is a tricky one. It's kind of hidden in here. We haven't really talked about this. But when you, let's say, want to estimate your taxes on a bill, let's say it's 6%, you can take your bill times 0.06 and then add that on top of your bill. Or if you multiply by 1.06, this 1 represents your bill, how much you spent in the store, say $35, and this represents the tax, 0.06. This also works with tip. So if you wanted to find out your total bill with a 20% tip, you'd multiply by 1.20. It saves you the step of having to add. Well, this problem, like I said, is kind of hidden, but this 0.11, this 1 represents the whole amount. The 0.11 means 11%. What should the company be worth in 2025? Well, that's 2025 minus 2010 is 15 years. That's a t, time. So, use the equation y equals 251 times 1.11 to the 15, and that gives you 1,200, and remember, it's million years. 63. Write an exponential function for the situation. Okay? Oops. Lost my page, sorry. So future value, we don't know. 600 times 1 plus 0.11 to the 5. There's your 11%, there's your 5 years, and there's your starting amount. And if you calculate that out, then estimate after 5 years, you're going to have about 1,011 animals. Okay, 64. A is equal to 80,000 times 1 minus 0.24, because it's decreasing, to the 7th power, 7 years. When you run that through, you get about $11,716.16. 65. Half-life. So if it's starting at 100, we do 50 here equals 100 here. E to the negative 0.035 times t. What do we do every time? We divide by 100. That's going to give us 0.5. Because 50 divided by 100 is 1/2. Equals e to the negative 0.035 t. Once again, you could put this in the calculator and scroll until you get to the amount they're asking for, or you could just do it this way, log both sides, makes that disappear, and then divide by 0.035. So ln 0.5, close parentheses, divide by 0.035, and you get a t of about 19.8 years. 66. You're given the formula right here. You're starting with 50 grams. After 10 days, what's going to happen? So A equals starting amount, E negative 0.04463 times 10. All you're doing is running that through the calculator, and you get about 32 grams. 67. Here's your formula. Future amount is 3.5 million. E to the 0.015 times 30 for 30 years. Run it through the calculator, and you get about 5.5, and don't forget, it's million. And last but not least, 68, the population P in thousands. There's your model. And since it's in thousands, I'm going to just treat it as 120 to make it easier. Because if I put 120,000 in, I'm actually going to inflate the number. Because since it says in thousands, we actually just need to be 120 and then the word thousands. So 120 equals, starting amount in the equation, 50e, 0.015t. Again, we do the same thing every time. Get e by itself. That gives us a decimal over here, equals e to the 0.015t. What do? We log both sides. Ln e goes away. Divide both sides by 0.015, which gives us t of about 58.3 years. Remember, ln 2.4, close parentheses, divided by 0.015. There you have it. There you are.